Hello, everyone. This is Barb Tyson, and today we have Gino Morrelli of Morrelli, Melvin Design and Engineering Incorporated with us. He'll be discussing catamaran heavy weather tactics in today's Salty Dog webinar. Just a couple of reminders before we get started. As always, please keep your video off and keep muted. That'll help us keep things running smoothly for everyone. But if you do have questions during the webinar, go ahead and type those in the chat box that I've opened. And Gino says he's going to probably be answering those questions as we move along today. So go ahead and type them in as you think of them. And now I'm going to hand things over to our Salty Dog president, Hank George.
Well, good afternoon, everyone. Thank you for joining in on our last webinar of our webinar series this year. We've had a great series, a lot of wonderful speakers. Gino has given us an excellent talk earlier, and today's talk I'm sure we'll all find very informative, talking about handling our multi-hulls in rough conditions. So Gino, I think, as most everyone knows, is extensive design experience, world leader with Morrelli and Melvin in design of some pretty amazing vessels, America's Cup winners, long distance record-setting multi-hulls, and Gino's been aboard those boats, so has firsthand experience that it will be very helpful to us. So I'm going to turn it over to Gino at this point. Thanks for being with us again, Gino.
Sure. Thanks for having me back. Today's seminar is mainly about heavy weather sailing and catamarans. And I'll generally cover kind of the hot topics, primarily focusing on what probably are more mainstream catamarans, the production, Fountain Pajots, Leopards, Lagoons, etc., as opposed to the more crazy extreme boats that we get involved with. Let me make sure I got my screen here. See. Okay. Can you see my full screen here? This is kind of the start. Great.
Yep.
Okay.
That's perfect.
So, heavy weather, this is usually what we try to avoid. And especially these days with, the satellite coverage and weather routing and a little bit of planning, you can pretty much avoid these catastrophic full gale, hurricane, situations. In the big picture, most people, if they ever in their entire life end up in this situation, it's pretty rare. I mean, I've been forced into this situation once or twice over like 40 odd years of sailing, multi-hulls around the planet, in the Pacific, Atlantic, South Atlantic, Cape Town, all over the, Mediterranean is probably the worst place I've ever been. But avoiding it is your first tactic. By a little bit of proper planning, you can usually avoid the worst of this kind of situation these days. Now, some of our experience dates back, to boats like PlayStation, which we did race, fully crewed around the world. And reefing is, one of the primary design problems on all boats. And as you sail multi-hulls any amount, you'll quickly appreciate that going fast isn't the problem, it's going slow. It's figuring out how to slow down. And it's figuring out how to slow down and keep everyone comfortable, don't break the boat, enjoy it, as opposed to running around like we did on PlayStation, wave jumping out of 20-foot waves and going 30 knots. But even in this case, you can see in this photo, we've got our smallest jib up in a triple reef main, and we're still trying to figure out how to slow down. And even though we're going, mid-20s here, it's not something we wanted to do for very long because it's really boat breaking conditions when you start going upwind in these kind of sea states. But all this bad experience taught us a lot about reefing. And in the case of PlayStation, it literally would take 6 to 7 guys 18 to 20 minutes to take a reef or to unreef. Back in those days, the mainsail alone weighed 2,000 pounds. So it was, 6 guys on grinders, a couple tailors, and a helmsman wrestling the thing up and down. So it was an exercise in calories. We figured out how many calories we'd burn reefing and make sure when we reefed, we needed to reef, we reefed early, and we reefed intentionally. Now, most of the focus on today, I'm going to talk about more recreational boats. This happens to be one of our new HH 50s called Lickety. And this is more typical sized of what I imagine our audience is thinking, somewhere between 55 and 40 foot is probably the brunt of the market. And generally, these types of boats these days either have single helm to starboard or dual helms. And depending on the deck plan, halyards lead aft, reef lines lead aft. In the case of most of our kind of higher powered boats, we try to lead all the halyards and reef lines and tack lines aft as much as possible for several reasons. Safety, short-handed, usually it's a couple sailing the boat, or it's a guy, single-handing with somebody off watch. So we do as much as we can to facilitate making it easy to reef, because again, the primary safety is trying to slow down. And in this case, we've had to evolve our systems to handle the loads. And 15, 20 years ago, we would generally have slab reefing, but we would use single line. And when I mean a single line reef system, that was kind of the system where if you pulled one line, it pulled both the tack down and the clew down at the same time. And then your reef line was under load continuously. The trouble with the new, more modern multi-hulls, and even like, the Outre-mers and the Fountain Pajots and the Lagoons, the mainsails have gotten so much bigger and the loads have gone up so much that we can't really tolerate single line reefing anymore. So we've had to go to slab reefing with independent luff and tack lines. And in a lot of cases, we found that reef lines under load are really prone to chafing, especially the clew loads. And in the case of a modern catamaran, you could see anywhere from 2 to 3 tons of load on the clew and only 1 ton on the luff. And that's one reason single line reefing doesn't work anymore, is because the loads are so asymmetric. The sheet load is so much higher than the tack load. So we've evolved to boats that have really robust, dedicated reefing systems. And that's what I'm going to kind of show you a few more photos of. This is kind of another cross section of 50s and 55s that all have similar setups. Now, if you bought a boat practically in the last 15, 20 years, you got an owner's manual. And part of the EC ISO requirements in your owner's manual, at least for I think the last 10 or 15 years, is a reefing chart. And your manufacturer, designer, ISO spec makes the manufacturer prescribe the reefing sequence. And in the case of this sequence, this is for an HH 55, happens to be TTR, Ticket to Ride. And you'll see this in your owner's manual. So if you don't have an owner's manual, you probably can go online and dig one up somewhere, or go back to the manufacturer or the dealer try to get one, because it should be in your owner's manual. And in this case, we can see, kind of starting on the upper left-hand corner, full main. And in our case, we have what we call a Solon, and it's basically an overlapping jib. And then, that's like 0 to 22. And this is apparent wind speed. And the apparent wind speed, of course, is what you read out on your instruments. It's what you feel in your face, as opposed to true wind speed, which can be quite different. And on most boats that we're commonly talking about, there's not a big difference in true wind speed and apparent wind speed going upwind. Maybe you're sailing at 8 knots in 12 true or something like that, as opposed to a really fast boat these days where we might be sailing at 16 knots in 12 true and the parent's at 28. So it's a much higher factor. In the case of a conventional multi-hull that basically has kind of a big fathead main and either an overlapping or a self-tacking jib, generally we reef the main first. And in most cases, we'll progress from a full main, an overlapping jib. In our case, we'll shift down to a staysail. And in most of our ocean going, and these are primarily ocean cruising boats, so they're kind of set up with a few more sails and more hardware, so we can change gears relatively easy, because nobody wants to actually take a sail down, so they're all furled sails for the most part. So at around 22, 21 knots, we start parent going upwind. We'll prepare and set the staysail. And most of those sails are on free-flying luffs, and they have locks at the top and perches at the bottom. And that's what we set up as a staysail. So we furl the big jib and then unfurl the staysail. And as we progress through the wind speed ranges, we keep reefing the main and keep sailing on the staysail till we get all the way to the third reef practically. And then at that point, one of our normal tactics is, if we're looking at the weather and we know it's going to continue to get windier, we'll preemptively pull a storm jib out of our sail locker. And I'm a big fan of what they call ATN gale sails. It's a type of storm jib that you actually put over the outside of your furled up big jib. And I'll show you a picture and a slide of those in a bit. But normally, as we get down into a higher and higher wind speed, obviously you're just shedding sail area as quickly as you want. Now, a couple things that we kind of joke about on board is if you've got a relatively new boat, you might even have a digital barometer on board, or you have an old analog style, or you've got a barometer with a gauge. And when we were racing PlayStation, we noticed this phenomenon that we were going fast enough that we could watch the barometer drop as we sailed into a low. And depending on the slope of the drop of the barometer, we could predict that in 1 hour we're gonna reef, in 2 hours we're gonna have to reef again, in 3 hours we're gonna have to reef again, because you could watch us sailing into a low pressure system so fast that we would be colliding with this descending barometer. And we started figuring out quite quickly, if it took us 30 minutes to reef, we'd only be sailing for another 30 minutes, and then we'd have to reef again. And then another 30 minutes, we'd have to reef again. So we quite quickly learned that in a building breeze, we would very frequently take 2 reefs right away, because it was so much cheaper energy-wise and safety-wise to take 2 reefs at the same time. And one of the things you'll find with these newer modern fathead mainsails As soon as you start to watch the leach blow off, you lose, you don't have enough main sheet tension to hold the leach up anymore. You're basically creating a lot of drag. So it's actually faster to sail with less area really quick. And a lot of times people on multi-hulls will be surprised that, you know, it's windy, we're going fast, you know, maybe we're going upwind or we're reaching a bit, and we take a reef and we don't even slow down. Well, part of it's because for the last 30 minutes, somebody's been traveling the main down or letting the leach twist off, or the sail is stretching and twisting off. And as soon as you reef, you get everything back into shape and you're going faster again. So it's quite common to find, if you don't reef, you know, basically as soon as you think about it, it's too late. And if you are hesitant, take two. I mean, reefs are cheap. It's so easy to take two at a time, especially if you're sailing into more breeze or you're sailing into the evening or darkness, or you're just tired. And the typical multi-hull surprisingly sails, you know, quite well, because, you know, the power of the sail is velocity square. So it doesn't take much increase in velocity to be right back at the same power. So we're something to think about and keep in mind is, you know, reef early and reef a lot, especially on a boat with a bigger fathead mainsail, as opposed to the more old-fashioned kind of what we call pinheads. In your owner's manual, there'll be a page that basically puts that same information from the diagram into you know, numbers here. So you can see it, the predictions. And normally we prepare, as the designers of these boats, we prepare this document with ISO CE, you know, the European Community regulations that are kind of like the building codes that almost every catamaran in the world is production catamarans built to. And these operating conditions have safety factors in them. So you can look at them with a bit of grain of salt. And the main thing about wind speed is it's really not the biggest driver of wind or reef. Usually it's sea state. And if you're in, you know, open ocean, long swell, no cross swells, you know, you can probably push your reefing back a little bit because it's not too rough. But if you're in a tidal situation, or there's cross waves, which are quite frequently where multiple weather systems are crossing each other, you could easily reef, you know, a whole jump sooner just to keep the boat comfortable. And especially cruising, you know, deliveries, you know, the goal is not to race around with your hair on fire. You know, the goal is to get there safely, don't break the hardware. You know, we always say preserve the assets. And in a race boat, it's the boat, and in a cruising boat, it's the crew. So, you know, you don't want to push your boat to the point where people are getting uncomfortable or bouncing around or can't sleep. I mean, there's a certain level of comfort that a cruising boat needs to, you know, respect, just to keep everybody safe and you know, rested. And so jumping, you know, the reef situation up or down a notch is very dependent on sea state. Some of the caveats at the bottom of this document are always probably something might be unique to your boat. On our boats, we were able to sail with a what we call a hound height or reacher with a reef, and that ends up with the jib is much higher than the mainsail. And some manufacturers, their boats, their rigs can't tolerate that. So you have to be careful about setting off the wind sails higher than your headboard, because the mast isn't built to take that kind of what we call tip loads without the mainsail up there helping to support the mast. Because in a modern boat, the actual mainsail does actually help hold the rig up. And you probably noticed that if you do if you do reef and it's really rough, the mast could be like jumping all around and wiggling. And sometimes we'll do a trick where we'll put the topping lift on the back of the boom and sheet the topping lift on a little bit just to pull the head of the mast back and help keep the mast from bouncing around. And it's kind of a cheap topping, it's kind of like a cheap backstay. And you can get away with that on certain boats and help slow the oscillations of your rig down. So that's kind of a trick to keep in mind, because you don't want to necessarily have your mainsail sheeted super tight in heavy air, because you need to let it twist and absorb the puffs, but you'd like to have that top mast support. So taking your topping lift to the back of the boom and kind of adjusting that so that the topping lift's actually taking maybe half of the main sheet load and the other half is on the sail. That's a good trick. The other things in here, balance, which is the amount of feel or amount of pressure on the rudder, is driven a lot by the sail plan. So if you have a big mainsail and a little jib, the center of effort, center of pressure is pretty far aft, so the rudder gets a lot of load. If you've got a big jib and a little mainsail, the center of pressure moves forward. It's kind of like a windsurfer. You move the rig back and forth and you steer the boat. Same thing on a big boat is we can shift the center of effort, the center of sails fore and aft by the different combinations of big main, little jibs, or vice versa. And normally we like to set our boats up with what we prefer is just a little bit of weather helm all the time. So if you let go of the helm, the boat will round up slowly into the wind. And we don't want it extreme because it's a lot of drag, because then you have the rudder trying to keep the bow from heading up. So you turn the rudder the opposite way and there's a lot of drag. So and what's a lot? It depends on how good your steering system is, because a lot of boats' steering systems are so stiff, you can't feel what we call feedback from the rudders. But if it's more than a degree or more than 2 degrees or 3 degrees on your rudder, you're probably sailing with a lot more weather helm than desirable. If you've got an autopilot hooked up, the autopilots all have rudder angle indicators. And if you just turn your autopilot on, you can see what your rudder angle is in every condition. And it's kind of interesting. And you can kind of play around sometimes with mainsail trim and jib trim and watch the rudder angle indicator reduce or get bigger as you change the pressure of the sail. And it's kind of a way to tune the pressure, but in general, you don't want to have a lot of weather helm, and you certainly don't want leeward helm where the boat's trying to bear away on you. That's really slow and can be more prone to accelerating as the boat speeds up as it bears away, as opposed to heads up and slows down. So the preference is to have the weather helms to be able to have the boat head up. And that's the balance. Let's see what else is down there. Yeah, if you're ever nervous, depower. Take your foot off the gas. We don't have brakes on boats, but we can take our foot off the gas, and reefing is the best way to slow down. Up to the point where everything's down, and then we've got another situation where we're talking about drogues or artificial ways to slow down. But generally, knock on wood, you'll never be in that situation where you really have to face how do we slow down when we don't have any more sails up. Okay, I see the next step here, and this should be in most of your owner's manuals. It basically talks about your riding moment, which is the stability of the boat. Now, your typical Leopard, Fountain Peugeot, Lagoon, mainstream production boats are really relatively underpowered. And they usually don't have really good sails as opposed to having like an all carbon mainsail. And a lot of times the main sheet system is block and tackle, and it might be a 4-to-1 and goes back and forth and leads to a winch. And that elasticity in the sails and in the main sheet system basically make it nearly impossible. I won't say impossible, but makes it nearly impossible to capsize one of the more modern type catamarans, because generally they're pretty wide and they're pretty heavy, and the rigs are pretty conservative, and the sails are relatively conservative as well. And elastic. Elasticity is your friend. In fact, a lot of times when we launch one of our new HHs and the owners, a typical HH can fly a hull. And when I say fly a hull, I mean it can capsize, in wind speed that we know and we predict quite accurately these days. A typical HH50, we think it's relatively conservative. It's full mainsail, full Solent, and 25 apparent, which is pretty ragged if you've sailed a boat in that much breeze. And in that condition, you can fly a hull. If you can fly a hull, you can capsize. Most production boats, we designed a bunch of the Leopard series, the 38, 40, 46, 44. And by design, those boats were intended not to be able to capsize. If you've got a boat with mini keels as opposed to dagger boards, you're even less likely to ever get that thing up on one hull. Dagger boards are just so much more efficient, and the downside is that they help you fly a hull, or that could be the upside. But if you're on a dagger board boat and like an Outremer or a gunboat or an HH, we also have this trick we call our first reef. And by raising your lure dagger board about 3 feet, it's like lowering your mainsail about 6 feet. Because it's the distance between the center of pressure of the sails and the center of pressure on the dagger board. It's this distance that if you reduce this distance, it takes much more pressure to get the boat to turn over. On a mini keel boat, it's fixed and it's quite shallow, and it's not as dramatic. But on a performance catamaran, the dagger boards are up to 14 feet deep now. So we can grow this distance quite a bit. So our first reef might be to raise the dagger board 3 feet, which is like lowering the mainsail 6 feet. So a lot of times when we're sailing these higher performance boats, the first reef is to raise the lure dagger board, which seems kind of funny, but it works because you're reducing that distance, that couple between the center of pressure and the center of lateral resistance. And it's a cheap reef. And you can do it on those boats by pushing a button, because the dagger boards are on electric line drivers. So if you've got an Outremer, a Katana, a boat with dagger boards, raising your lure board is just like lowering your mainsail. So that's something to be aware of. Generally, the documentation you get from the owner or from the manufacturer assumes the boat is in its lightest condition, because that's when it would be most prone to heeling or capsizing. And that's why a lot of times you'll see in this documentation, it specifically states which displacement. And a typical catamaran can vary by 2 to 4 tons, depending on the amount of toys and books and water and fuel and spare parts and rock collections and everything else people want to carry, wine. So keep in mind that a lot of these estimations of when you should reef are based on a very light boat. the downside is a heavier boat just loads up everything more. But typically when we have a boat that we design to ISO CE specs, you're required by the Scantling rules, the building codes, to build the mast and the rigging strong enough to sustain the highest load possible of the yacht. In our case, it's to full riding moment, capsizable, and our safety factors are quite high because we want to be able to do that. Generally, on a production cruising boat, because you can't fly a hull, the safety factors at full riding moment are sufficient that if you ever did, there's not a manufacturer we've ever worked with that says, I'd rather the rig fail than the boat capsize, because the shock loads and the fatigue and all the other things that go on with boats would eventually catch up with you, and you drop a rig on top of someone's head that wasn't even close to capsizing, because 15 years from now, it's something's fatiguing. So there's no in our office we never purposely design a rig that's going to fail until we get to huge boats like 100-footers or 90-footers, and then we put automatic hydraulic pop-off valves on the main sheet to restrict the loads.
And Gino, we do have a couple of questions.
Sure.
We have from George, how many reefs would you recommend on a mainsail?
Typically 3 is our normal amount of reefs. And let's see if I go back. Let's see if I can go back here. Yeah, the way we typically look at it, I don't know if you can see my cursor or not. Our first reef is about at the head stay. Our second reef is basically between the head stay and the spreader. And the third reef is at just about the spreader. And this is intentional because structurally, that's where the panels are the most supported. And it works out structurally for us the best. There is a funny situation with some racing rules that you have to have storm trysail, actually, Bermuda race. Multi-hulls were kind of an addition just a few years ago. And most monohulls in that race have to have a proper storm trysail. And those are really impractical on catamarans. And so we were able to negotiate the ability to sail with a third reef so long as it wasn't too big. And but generally, 3 reefs is our normal preference. Now, going back to the question of the loads on the clues, we've become a big fan of one of 2 products. One's built by Faulkner, a French company, and it's called a clue lock. And it's this stainless or aluminum mechanical thing that you attach to the boom. See, I don't know if I can make this any bigger, but I'll show you a video here in a sec. Basically, what it allows you to do is reef from the cockpit and have the lock securely attach the sail to the boat. And in our situation, normally when we set up 3 reefs, we suspend these locks by bridles fore and aft. And this line aft here, this is the line that comes usually from the outhaul box in the back. It goes through the lock up to the sail and back down to the lock. And as you grind down the reef line, it pulls the sail into the lock. And I'll show you a video here in a second of this happening. And we've been working with both Faulkner and Carver, 2 French companies that have been developing these products for quite a few years, mainly for the French ocean racing scene. And let's see, here we go. So this is a Faulkner lock, and sails being ground down into it, and you get this nice reassuring click. And especially when you've got a boat with a cockpit and the boom is well above your head, you don't always have enough people on board to manage this. So one of the advantages of this is that you can set these systems up, mark the reef lines, and then pretty legitimately be able to reef from the cockpit and know you're going to get that in. Most of the multi-hulls these days with bimini or a raised pilot, and then the boom is even higher. The last thing you want to do is have to get up onto the boom and put the reef in. And before, kind of old school, we would do this whole system with lines, and then we'd get up on the boat and put a safety around the boom and through the clew of that reef. And that was acceptable when you had a bunch of 18-year-old knuckleheads running around who would do that kind of stuff. But most of our owners are, 50 years old and older, and we're working out these kind of remote systems to safely allow them to reef from the cockpit. And these type of systems still have some bugs, but they're getting better. I'll show you one more. Now, this is different boat. This is a HH50, and this green line is the trip. And what it does is the hook's got a latch on it, and when you pull the trip line, it lets the clew loose. I'll play it here. I have to watch it here for a sec. It doesn't take much for the trip to get pulled. It moves about a ½ inch, and then it's tripped. So the trip line leads all the way to the cockpit. And generally, when it's well set up, we put a 2-to-1 in the system, and you can pull it by hand. And then even under full, relatively high load, it'll trip the lock and release it. Now, there's a lot of effort to do all this, but the benefit is once it's hooked, you don't have any lines loaded in the boom, and you reduce the potential for chafe to near zero. Because what we found, and we've tried spin locks and jammers in the boom and on the deck, and basically a jammer is a guillotine. Eventually, it'll bust every line that we put in it or strip the cover. So we've ended up with a preference to locks, and these work day and night. Once they're set up and you get comfortable with the sequence of lowering the main, easing the main sheet, grinding down the clew, hooking it, then grinding down the tack. Some of our more experienced HH owners, couples, can basically reef going upwind in 3 or 4 minutes. Once the lines are marked and there's a bit of practice, it's not as dramatic as one would imagine. And you really need to consider this as almost your first line of defense in slowing down, is being able to reef easily and reliably. This is a carver. So this is very simple one, no mechanical parts. It's just a giant chunk of aluminum. And once you pull this line, and the guy gets his head out of the way and releases the reef line, it'll let go of the strop. And there's some differences between what we call a carver hook, which is this aluminum version here, and the Falknor hooks. The preference is the Falknors, you can't set up the bottom of the mainsail quite as tight. You have to let the sail have a little bit more draft, where the Falknors, you can have a quite flat bottom of your main. And that's good for reducing power, because the last thing you want when you're reefing is more power. You're trying to go slower. You don't want a lot of power. And what we found is the Falknor hooks with a trip line let us have a better mainsail shape. The carvers are cheaper and really reliable, and you just give away a little bit of mainsail shape. So it's not a big problem to go either way. Now moving on to storm jibs. And as I mentioned earlier, as we reef our sails down, we go from the what we call the forestay solent, which is the structural stay holding up the mast, to a staysail. And what I like is to be able to set one of these. This happens to be built in Florida, a company called ATN. It's called a gale sail. And it's kind of cool because what you can do is wrap it around your headstay with the furl jib still on the furler. So if you're sailing upwind or downwind and it's getting windier, and you know you're going to end up with your storm jib up quite 2 hours, 3 hours earlier, you can, while the conditions are still fairly reasonable, you can go up and hank on the gale sail around the furled big jib while you're sailing on the little jib. And you can raise the storm jib with a spare reacher halyard or a spare spinnaker halyard, because the sail's quite small and there's not a lot of load on it. And when you raise and lower it like a conventional sail, it's not a furled sail. So when you're not using it, you can even lower it back down to the deck. If you were going through a progression of reefs where you're on your staysail, it's getting windier, you put your storm jib on, you drop your staysail, you raise your storm jib, and then as it starts to get lighten up, you might go back open with your staysail and back down with your storm jib, and be able to switch gears a lot easier and basically at your leisure, because you can put this thing on and off quite conveniently. And they really don't require any additional hardware, and they're relatively inexpensive because they're really small. I think on a HH50 they're like $2,500 or something. And now they actually make them all orange to comply with ORC regulations, Ocean Racing Council regulations, and it makes them very, very high visibility. So that's one of my favorite products that we design around a lot, this storm jib. Let's see. Now, one other tool that I like to make sure our owners get a hold of is a good preventer. And a good preventer is basically on a multi-hull where we don't have vangs, because we probably just tear them off the mast because the mainsails are so big, is generally we have to have a preventer when you're running downwind to control the twist in the mainsail. Depending on your boat, you probably have a track on the back beam or a track on the cabin top, and that'll allow you to let the main off, maybe so the boom is just inside the leeward hull or somewhere abouts. But you really want it to go a little further because you want to sail deeper. You want to sail more downwind, as opposed to sailing, hotter angles with your hair on fire. Most of our cruising owners really prefer sailing the boat deeper, like at 155 to 165 true wind angle. So almost perpendicular with the waves. So the boat is kind of contouring downwind and surfing a little bit, much smoother on board than sailing, hotter angles where the boat's kind of doing the cattywampus. So sailing deep requires a good preventer. So we've been fooling around with better and better preventers for the last couple of years with some of our owners, because you want a combination of elasticity and shock absorption and adjustment. This is one we've been experimenting with on HH55 Ticket to Ride. And here's a little video of it sailing off in Hawaii. So it's basically got a block and tackle system at the bottom. It's got shock cords that span, this kind of 8-foot gap. And then in between the shock cords is a nylon, this happens to be a 3-strand nylon line that ultimately restrains it. So it allows you to still sail with some twist and some elasticity because on these big fathead mainsails, going downwind, they really like to twist open or they're all stalled. So to get the best benefit of the mainsail downwind, you need to sheet it outboard as far as you can without the sail touching the shrouds, and then trim the preventer down to control the twist. And so this combination of the main sheet on the right and the preventer on the left kind of re-triangulate the main sheet. And it's also good for when you're reefing, upwind or downwind. When you've let off the main sheet system to take a reef, you can set up your preventer and it keeps the boom from wiggle waggling so badly. And it makes it easier to get the sail reefed. This is just a close-up of the, this was kind of a cool 3D printed aluminum infitting we designed that we've been testing out with TTR. So it's a combination of shock cords around the outside, and then on the inside is another eye, kind of like this, that holds the 3-strand nylon, which is super elastic. One of the funny things we were working on with Frank Stitch, the owner of this boat, is a couple versions were really noisy. And as it, with elastic back and forth, it would squeak and it was really obnoxious. So we had to experiment with different lines and different shock cords to find one that not only worked, but it was quiet. Because if you were sailing downwind at night and you were sleeping in the aft berth, it would keep you up. It was just squeak, 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 squeak. So there's been a little bit of R&D going on to get all that right. In this photo, you can see the preventer is on the outboard side and the main sheet's on the inboard side, and that's where we're triangulating to keep the boom in about the right spot, yet not sheeted down so hard that the leech closes and the mainsail stalls. So a good preventer needs to have elasticity. It needs to have some range because, depending whether you're going downwind deep, different reefs or different conditions, you want to be able to adjust the tension. So that's been a fun thing we've been fooling around with for the last year or so. I think I got about 10 minutes left. So Barbara, if you've got any more questions, I'd be happy to take them.
Yes, I've got a couple of them here. Philip wants to know if there are any different considerations for the Prout's aft mast rig. He's saying maybe small main and large jib.
Yeah, if you go back, with bigger jibs, you basically end up with a situation where you're changing jibs, or you're you might have a triple Hetzel rig. You've got your biggest light air jib, and then you've got a medium, upwindy kind of sail, and then you've got an even smaller upwindy sail. And if they're all on furlers, you're probably changing jibs before you reef the main. It's almost like an old IOR boat. where you reef the jibs first, or you change down jibs much faster than the mains. It would change your strategy a little bit. Normally, I would imagine if a multi-hull has been built in the last 10 or 15 years, it's probably what we call a main dominated rig. Even the latest lagoons, which have really moved the mast back over the last 10 years to make the main smaller and the jibs bigger, still probably prescribe a reef in the main first. But it'd be good to consult your owner's manual to see if there's some clues about what to do there.
Another question from George. What percentage of the mainsail is optimal for the 3 reefs, particularly the 3rd reef?
Oh, we don't really look at it too much in terms of percentage. I mean, I could go back and look at the numbers and divide it out to figure it out. It's usually the first reef is the smallest one, and then the next 2 are equal or slightly bigger. It's probably, I don't know, 18, 22, and 25 or something like that. I'd have to go do some math to figure it out. But we reef more in relationship to the rig from a structural standpoint, because we don't want the head of the main in a reef condition to be pulling what we call mid-panel between the spreader and a diamond. We typically, most of our rigs are what we call single spreader, double diamond, top and bottom. And that provides nice support both laterally and fore and aft for the rig. So we always like to try to get the head of the main to intersect one of the diamond connections or a forestay connection. And that typically drives our reefing schedule.
We have another question here on chafe. Philip says he's changed the reef lines to 10 millimeter Dyneema with some help in reducing chafe. He's considering junking the single line system, which he never liked anyways. Yeah. Will he see a further reduction in chafe?
For sure. Yeah, I'd be thinking about trying to hook. The carvers are more economical. Typically for this type of boats, plenty good. It doesn't take much change in your hardware because you've already got the outhaul on the back. You might have to add a strop around the boom to hold the hook in the right place. But yeah, for sure, once you're on a hook, there is like no chafe. In fact, one trick we do is the back of the mainsail typically has webbing loops that come down and form as opposed to a pressed in ring. Most mainsails of this size, the rings aren't strong enough anymore. So they had to go to sewn-on webbing around the back of the sail. And usually it's like 3 or 4 webbings coming together, like in some of those photos. And rather than hook directly onto the sail, we'll put an intermediate loop of webbing, maybe 6 inches long. And you can make the loop yourself, or you can get a sailmaker or rigger to make you a loop. And it goes through the clew of the sail, and then the hook hooks onto the loop. And then after a number of year or 2, you can replace the little loop rather than having to take your sail into a sailmaker and have him replace the webbings, which is a lot more expensive. So putting an intermediate loop, I showed it in my little slide, but I didn't point it out. But that's a good trick to saving some chafe.
Mickey wants to know if you would discuss heaving 2 options in heavy seas. He says that his experience is that cats don't exactly heave 2, but can be slowed considerably. Problem is that the main sheet on his FP can't be released enough before touching the spreader.
Yeah, if you're trying to go head to wind kind of heave 2, you probably could, again, if you had a decent preventer, you could probably travel down and preventer a little further outboard, but you definitely don't want your mainsail into your aft lowers or shrouds or spreaders, or kill your main in a matter of hours. And typically, if you do go head to wind and you set it up with the main with just a touch of power, but you put the rudder at the opposite direction, the boat has a tendency to head up with the mainsail power, but then as soon as it gets a little speed, the rudder turns it back off the wind, and it kind of sits there and almost parks. And that's a good way to like park a boat without taking all the sails down. It's just to travel down and almost like put the helm hard over. So the helm is trying to make the boat head off, and the mainsail's just sheeted in just enough to head it up without a jib up. And you can kind of park it with the main up with a jib down, and it'll sit there at about 50, 60 degrees off the wind and almost just go sideways. It won't even go forward. It'll just kind of go forward a little bit, sideways, forward, sideways. And that's a good way to park it.
Another question here, a double question. Why do you say not to go downwind with just the main up? Why do you say not to go downwind with only a spinnaker up?
Yeah, that is kind of a curious. I noticed that when I was, that's whoever picked that out was pretty sharp. Yeah, I was going to question that myself. It's like, why can't you sail downwind with just the main up? There's no structural reason that you couldn't do that. There's no, I mean, it'd be out of balance. The worst thing is it'd be probably a ton of weather helm. But structurally, there's no reason that you can't sail downwind with just the main up. I'm not quite sure how that snuck into the owner's manual, but it would probably be an issue of if you just had a full main and it was blowing 25, or 30 knots, you'd have a ton of weather helm, and the boat would constantly be trying to round up, and you'd be constantly having to turn the boat down. So it kind of, works the steering system a lot. But structurally, it's not an issue. Now, the other side of the coin, though, is it's usually the mast isn't built strong enough to sail downwind with a masthead spinnaker with no main up on an aluminum rig. Our big carbon rigs, we actually design them to be able to do that. But your typical aluminum rig, fractional rig, where the head stays down from the top, 18, 15%, usually isn't strong enough to take full masthead loads without breaking. If it was a hound height, where the spinnaker was flying from the intersection of the head stay and the mast, you can pretty much get away with murder there, but you couldn't on a masthead. It really would be rig and boat dependent. 2 knots of wind, it's not a problem. 30 knots of wind, it might be a problem.
Our next question is, how do you feel about parachute anchors?
Seen them, never used one. Used storm drogues twice in my life. Yeah, I've seen them and read the accounts and talked to folks who've done it. It seems viable. I think some cases people find them a little bit harder to retrieve, which is probably the least of your problems. If you're trying to slow down, retrieving it's probably a good sign, because that means you survived and it's over. But that's about the only downside I've heard to a parachute, is sometimes they're hard to retrieve, as opposed to the drogues, the cone drogues.
That kind of leads to our next question. Can you discuss the needs for a drogue on a cat?
Yeah, it's, I guess it depends on your itinerary. If you're going to put yourself in a position where you are out of comms, you're going to be vulnerable to getting run over by a hurricane or a massive tropical storm. Normally, we build the boat strong enough to set the drogues off the pad eyes in the bow that we use for the anchor bridle. So structurally, that's where we would put a drogue if we were going, full park, going head to wind or head to the waves. And, for, if you were going to invest in that, I would for sure have I'd have a good storm jib first, and I think I'd do a drogue after that. Typically I'll tell you, most of our owners don't have them. Knock on wood, they haven't needed them either, going back a number of years, but I know you can get into trouble down off Cape Town, and you can get trouble in the Med. Yeah, I mean, for peace of mind, is probably worth the investment. And you're probably going to put it in a dry bag and stick it in your bow and never see it again until you sell your boat. But it's probably in those cases where if you were going to go cruising someplace where you were out of communication, couldn't catch the weather, couldn't talk to anybody, then might be worth the investment.
Eric says that he has a smaller cat, a PDQ 36.
Uh-huh.
He also says he's had no experience in storms to have real world knowledge, but his question is, he would think that a boat like this handles larger waves in a storm from 150 to 160 or 180, assuming this is a longer duration storm than just a thunderstorm squall line.
Well, the difference between running downwind and parking has a lot to do with, how much room you've got. If you're mid-ocean, I'd probably, and you want to go that direction, I'd probably run down with drogues as long as I could. But if it came to survival, you're typically better off going head to wind because the boat's built stronger to take the waves from the bow than the stern. Just the prospect of waves boarding the sterns from an overtaking wave and flooding into the boat and flooding the hulls is higher than the opposite direction, bow on. So I think your first strategy would be to run with it as long as you can. And then at some point, you're going to have to do a U-turn and go head to wind and park it. Because the boat can take the abuse, from the bow much, much longer than from the stern.
The next question is, please discuss speed limiting devices. I have a JSD, but have never deployed it.
I think we're all talking about the same kind of things. It's drogues, types of drogues, types of parachutes. Again, I think I've only done drogues twice, and they were both the conical versions. And we only had to sit on it for about 8 hours one time and only 4 or 5 hours another time till we could retrieve them and start limping the right direction again. I think I haven't really gone back and done a lot of research in the last few years about some of the latest developments, but there might be something better out there that I don't know about.
How much would a 6-foot drogue slow you down head to the wind?
Well, if it's blowing 60, it's one number. If it's blowing 35, it's another. Normally, what you want to do is try to restrict the boat from going backwards. And the worst case is going backwards fast enough that the boat will actually surf backwards. So you're trying to probably restrict your stern movement down to like 2 or 3 or 4 knots. But in all those cases, you really have to be careful about locking off the helm and make sure your rudder stops are really strong, because the last thing you want is the boat to go backwards and the rudder slam over and break something. So yeah, the goal would be going backwards would be not more than probably 2, 3, 4 knots.
What is your assessment of in-boom furling, such as leisure furl for 50-foot catamarans?
We've got a couple boats with in-boom furling, And the traditional problem that's still not really been satisfied is if you've got in-boom furling and you want to have any sort of positive roach profile, not a fathead, just a pinhead. Sometimes they are very difficult to furl without battens poking and chafing. It's not so much the furling's the issue, it's the chafe of the batten pocket against the front of the main, because a typical leisure furl in-boom furling system, it's not tracks and cars on the mast, it's just a luff groove. So the sail's got a bolt rope on the front. It's got a bolt rope on the front. And then if you've got a batten pushing against the bolt rope, we've had a continual problem with chafe where the batten is pushing against the bolt rope. And on a 50-foot boat with battens, you could have some significant forward compression in the battens that really chafe there. That's why we have special cars on tracks, because of the batten compression. If you built your rig 2 meters taller and basically had a hollowed leach mainsail or a super low roach profile that you didn't have full battens, you just had almost like a monohull mainsail with little leach battens, then you could probably get it to work well without chafe. It's always been this chafe thing that's been biting everybody who gets a in-boom furling that does any amount of sailing if they have battened mainsails. So you can kind of get around it by just, if you want to have similar performance, by just putting a bigger rig on it to make up for the lack of sail area and efficiency that you gave away from having a pin-headed mainsail.
I think we're caught up.
It to work.
Oh, sorry. I think we're caught up on the questions. Does anyone have any other questions for Gino? Time to type them in. Well, I'm not seeing any other questions right now, Gino.
Very good.
Well, Gino, thank you very much for doing this. I want to thank everyone for tuning in. We had a nice large group here. Great information from Gino. Barb will tell you a little bit about the recording so that you're able to go back and review some of this material again. But thanks again, Gino. I'll turn it over to you, Barb.
You're welcome.
Yes, thank you so much, Gino. Great information. We did record this, so I will get that uploaded and send it out to everyone, probably yet this evening. So thanks everyone for attending and have a great evening.
Thanks a lot. See you guys.